Right, last but not least, question 20, which was tricky. Okay, very tricky, mainly because it looks unfamiliar. Yeah, this is what I keep going on about right from the start. It's got a velocity time graph, which is possibly very different to every velocity time graph you've seen, because this is actually one which is a lot more realistic. Things do not travel with velocity time graphs with straight lines like that in the real world. They're always curved. Okay, so that's the little hurdle we had to get over. Firstly, but anyway, as the velocity of the car has increased, the driver changed gears. So we've got first gear, second gear, third gear, fourth gear, and then we're reaching where we're plateauing out because the car is reaching terminal velocity. Okay, it's reaching its maximum speed horizontally. Right. State how the graph shows that third gear has a smaller acceleration than in first. For a velocity time graph, acceleration is the gradient. Right, so the gradient for third gear on average is less than the gradient for first gear. That's as simple as it gets. Right, now use the graph to determine the average acceleration when the car's going in second gear. Right, now there's a little bit of wiggle room here, because obviously it's a curve, and where do you take your points? But all you needed to do was go, okay, well, let's take the extremities, why not? Okay, and then it's y change over x change, isn't it? Yeah, so it's going to be final velocity minus initial velocity divided by the time, which is that time there, minus that time there. Okay? So just trying to do that as carefully as possible. Should give you an acceleration of, what's it saying in the mark scheme? Question 20. Yeah, round about one. Well, yeah, no, it says in the mark scheme 0.98 meters per second squared. Okay, but like I said, there's, it allowed you to go, up to 1.3 meters per second squared, because obviously, where do you take your points? Little clue though, it does say average. Yeah, average, because like I said, this is the real world. Right. Use the graph to estimate the distance travelled by the car. This wasn't in the mark scheme, okay, because this is something I added. Right, distance is the area under, okay? It's the area under. Right, so how do you find the area? So it's the area from 60 seconds. Right. Because it's a curve, we've got counting squares. Right, counting squares. I'm not going to expect you, no one's going to expect you to count the tiny squares in this, but we can estimate the total number of full squares. Right, here's a really, really, really useful life hack for counting squares under a curve. Okay, count the number of full squares, and for partial squares, if it's greater than half, count it. If it's less than half, don't count it. It's as simple as that. So what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. This one's less than half. So I reckon 28. That will give you numbers of squares accurate to half a square, I think. Okay, so 28 full squares we've got to play with. So the area is 28 full squares. Right, one square. How much distance is represented by one square? Well, the amount of distance represented by one square is that velocity multiplied by that time. So it's, okay, it's really easy to go for this one here. 4 times 10, isn't it? 4 times 10, 40 meters. So one square is 40 meters. 28 times 40 is at 1,020 meters, I believe. Okay, Fairly straightforward. Right, the next bit was, I think, the trickiest question on the paper, because again, you really have to go, right, what is going on here? Okay, especially that table does take a little bit of effort to get your head around what's going on. But basically, we've got. I mean, when they do these tests for cars, they basically they hit the floor with the accelerator, so that they'll go maximum acceleration during gear 1. Okay, first gear, and then they'll reach the maximum speed, and they'll quickly change to second gear. They'll hit the accelerator to the floor and go at their maximum acceleration. All right. Now we're going to assume constant acceleration between gears, but we've got the values of acceleration, and we've got the velocities we're going to be reaching in each gear. Now, gives it in miles per hour. We have to convert, because some people still use miles. Right, okay. 1 mile is 1,600 meters. So, little cheeky conversion first. 60 miles per hour equals, okay, what, 1,600. Now it's per hour, okay. It's per hour. So we need to divide. Okay. Right, so let's start again. 60 miles per hour is 60 times 1,600. That is 96,000 meters per hour. But we want meters per second, so we're going to divide by 3,600. So the speed we want our car to reach, our maximum speed, is 26.7 meters per second. Okay? So that's going through the gears. We're going to reach maximum speed of 26.7. Right, what gear will we be in when we reach that speed? Okay, it's not first gear, because we need to change to second gear. Now, second gear, we can go all the way up to 32. So we're going to go through first gear. We're then going to change to second gear. Okay, to reach that speed, to reach 60 miles per hour, we go through first, and we go into second, and then we reach our maximum speed. Okay, right. So we need to do two different calculations. Okay, two different calculations. So I need the space here. So I'm going to, right, let's go with, so first gear, second gear, okay? Right, what values do we know? In first gear, we start from 0. We reach maximum speed of 18, don't we? 18 meters a second. So our max speed is 18 meters a second in first gear. The acceleration that is available to us there is 2.9. Okay, 2.9 meters per second squared. Okay, right. How long does it take to do that acceleration? Okay, what equation of motion we're going to use? It's got to be v equals u plus at, isn't it? Okay, so if we use v equals u plus at, that gives us an acceleration time of 6.21 seconds. Okay, 6.21 seconds. Right, that's the acceleration through first gear. What happens at second gear? Well, at second gear, we start off at the final speed of gear 1. So we start off at 18, and we reach our maximum speed, which, if you remember, was 26.7 meters a second. Okay. The acceleration available to us was 1.2 this time. Okay, so we've got 1.2 meters per second. Right, again, we're using v equals u plus at. okay? Because we know U, V, and A, we need T. So this gives us, in this case, the time taken to accelerate through gear 2 is 7.22 seconds. Now the total time to reach maximum speed is this time plus this time, which is 13.3 seconds. That's a hard question, okay? Right, but it's just a case of writing down what we know. Once you've got your head around the fact that we're going to be reaching maximum speed in gear 2, and once you realise that it's two different calculations, map it out. Map out the calculation like that. Write down what you know, write down what you need. Right, thank you very much. That is the lovely paper 1. I hope that makes more sense. Thank you.